Entropy and exergy are two fundamental concepts in physics that are used to describe and understand the behavior of energy in various systems. While they both deal with the topic of energy, they focus on different aspects and provide distinct insights into the workings of physical systems. Entropy represents the measure of disorder or randomness in a system. It is a statistical concept that quantifies the distribution of energy among the different states of a system. In simpler terms, entropy tells us how spread out or concentrated the energy is within a system. A high entropy value indicates a highly disordered or random state, whereas a low entropy value indicates a more ordered and organized system. Exergy, on the other hand, refers to the available or useful energy within a system that can be converted into work. Unlike entropy, which focuses on the overall distribution of energy, exergy provides a measure of the portion of energy that can actually be harnessed to perform useful tasks. It takes into account not only the quantity of energy, but also factors such as temperature, pressure, and the ability to transfer energy to other systems. While entropy and exergy are distinct concepts, they are not completely independent of each other. In fact, there is a relationship between the two known as the second law of thermodynamics. This law states that the entropy of an isolated system, a system without any interaction with its surroundings, always increases over time, as energy spreads out and becomes more evenly distributed. In other words, energy tends to move from more ordered states to more disordered states, resulting in an overall increase in entropy. Exergy, however, represents a departure from this trend. It is a measure of the potential to reverse such spontaneous processes and return the system to a more ordered state. Therefore, exergy can be seen as a measure of the available, useful, energy within a system that can be utilized for doing work. In summary, entropy and exergy are two essential concepts in physics that provide different perspectives on the behavior and utilization of energy within physical systems. Entropy quantifies the overall disorder or randomness of a system, while exergy measures the available useful energy that can be converted into work. By understanding and applying these concepts, scientists and engineers gain valuable insights into the efficient design and management of energy systems. Equilibrium in a physical system, entropy, and exergy may sound complex, but they all share some intriguing similarities. Let's dive into these concepts and explore how they connect. Firstly, equilibrium in a physical system refers to a state of balance or stability. It's when all the forces and factors within a system are in perfect harmony. Imagine a teeter-totter with two people of equal weight sitting on either end. That's equilibrium in a simple physical system. Now, let's introduce entropy. It's a measure of disorder or randomness within a system. When things become more chaotic, the entropy increases. Think of a neat stack of books on a shelf gradually becoming disorganized. The entropy is on the rise. In other words, entropy tells us how much energy in a system is not available to do useful work. This brings us to exergy, which can be thought of as the opposite of entropy. Exergy is a measure of the available useful energy within a system. It represents the maximum work that can be obtained from a given amount of energy. So, while entropy indicates how much energy is wasted or unavailable, exergy tells us how much energy is actually useful and can be harnessed. Here's where the connection lies. In a system at equilibrium, the entropy is at its maximum, and the exergy is at its minimum. This means that a balanced system with no potential for any more useful energy is in a state of maximum entropy and minimum exergy. Understanding these similarities can help us make sense of the natural world around us. From the way energy is distributed to the behavior of physical systems, equilibrium, entropy, and exergy play a crucial role. So next time you see a balanced scale or witness disorder in action, remember the fascinating connection between these concepts.